Estimation relies on you being able to round to one significant figure. These are non-calculator questions that you could lose a lot of marks on and spend a lot of time doing if you don't do the rounding first. So let's check we can round to one significant figure before we progress. We start counting significant figures at our first non-zero number. For example, if we had the number 3,201, that would be 1, 2, 3, 4 significant figures. So we do count the zero when it's within other integers. However, if we have zeros at the beginning or the end, they're not counted. So the number 2000 is only one significant figure. We do not count the zeros at the end. Similarly, we do not count zeros at the beginning. So that would be two significant figures because only the 2 and the 1 are significant. So just to be clear, the zeros in the middle do count, but the zeros on the outsides do not count on the beginning or at the end of the number. So 4 significant figures, 1 significant figure, and 2 significant figures there. So we want to round to one significant figure. That means that we only want one number followed by zeros. 3,381, our first figure, our first digit is a 3. That's our first significant figure. Now the number after that tells us if we're going to round up. 3,381 is closer to 3,000 than 4,000 because 5 or more we would round up, but because it's not, we round down to 3,000. 3,580, once again, we have our first significant figure. Is 3,580 though closer to 3,000 or 4,000? If this value here is 5 or more, we round up, so it's going to be 4,000. Right, the number 55, is it closer to 50 or 60? Well, because the 5, we're rounding up. Because of this 5 here, it goes up to 60. 22.8. Now remember, we're not going to 22 or 23, and this is where the errors would start to creep in. If you write 22, that's 2 significant figures. 23 is also 2 significant figures. So we're not going to the nearest integer, we're going to the nearest one significant figure. So once again, we just want that one digit. Now, because that's a 2, we're rounding down to 20. We do not need the 0.0 at the end because it doesn't affect the number. So these zeros here are important because they're placeholders. They keep the 3 in that 1,000 column. However, zeros after the decimal point are not required. 11.9 then. So 11.9, is it 10 or is it 20? It is not 11 or 12 because once again that would be 2 significant figures. So is it 10 or 20? Because that this number after the first significant figure is a 1, we're rounding down to 10. Finally, remember these zeros at the front do not count, they're not significant. So our first significant figure is that 4. Now the 4, are we keeping the 4 or is it going up? Well, the 8 after tells us that we need to round it up to 0.05. Once again, do not need any extra zeros after because they're not placeholders and the value would be the same, so 0.05. So you need to be confident of rounding to one significant figure prior to trying the next GCSE style questions. Okay, and this, I can't believe this was 3 marks. By rounding each number to the nearest 10, so there's 2 rounding that you have to do to one significant figure, but they're helping you here by telling you it's also the nearest 10. Estimate the value of 21 times 18. If you do 21 times 18, you get 0 marks. However, if you do 20 multiplied by another 20, because they've both been rounded to the nearest 10, nearest one significant figure, you would get 4 marks. And 20 times 20, I'm doing 2 times 2, which is 4. With 2 zeros at the end is 400 for your 3 marks there. Can you believe it? Okay, next one. Now this is a typical style question when it comes to approximating. Just remember that this is on the non-calculator paper, and if you do the calculation exactly, you would spend a lot of time and get no marks. By rounding each number to one significant figure, estimate the value of etc. So 1.98, that is going to the value 2. 3.82 is going to the value 4, and we're adding on 4.75 squared. 4.75 goes to 5 squared. 8, and we're adding on 5 times 5, which is 25. 8 plus 25 is equal to 33. There we go. Okay, is your answer to part A an overestimate or an underestimate? overestimate means, is our number bigger than what the real answer would be if we actually put in the 1.98 times 3.82, etc. Or is it lower than it's meant to be? Now this depends if you've rounded up the numbers normally or if you've rounded down, bar a certain, if you're subtracting, obviously you want to subtract the smallest amount, you'd want to have rounded down. But because we're multiplying and adding, these numbers just make a number bigger, and we've rounded up, ours must be a overestimate. Okay, so if we actually put the real values into the calculator, we would get less than 33. Give a reason for your answer. We have rounded up the numbers, which has increased our value. Next one. Miles is estimating the value of 1 over etc. She rounds each decimal number to one significant figure. Work out Millie's estimate. You must show your working. Okay, so once again, we need to do the rounding to one significant figures. 8.24 is going to go to 8. 10.41 is going to go to 10. Now this time we're actually doing 1 divided by the cubed root of 8 multiplied by 10. Okay, so the cube root of 8 means what number multiplies by itself 3 times to get to 8, and that would be the value 2. So it's 1 over 2 squared, we've got our squared off there, multiplied by 10, which is 1 over 40. 4 times 10 is 40, and that's your final answer. 1 over 40 would be absolutely fine written like that. Millie says my estimate must be more than the exact value without working out the exact value. Give a reason how you can know this. Okay, right, so this time it's a division, so we need to think about this a little bit clearer. Now, if you're dividing by a bigger number, the answer's smaller. Let me give you an example. If I do 1 divided by 2, I get 0.5. But if I'm dividing by a bigger number, 1 divided by, let's say 4, I get 0.25. It makes our number smaller. So the bigger number you're dividing by, the smaller number you're going to be. So if she says it's going to be more, then she must be dividing by a smaller number, which means we must have rounded down. So let's have a look at our values. 8.24 has been rounded down to 8. 10.41 has been rounded down to 10. Therefore, she's correct. We're dividing by a smaller number. Therefore, our answer must be bigger. Okay, so give a reason how she can know this. We are dividing by a smaller number due to rounding down, making the number smaller. Okay, and that's estimation. Basically, just make sure that you round to one significant figure before doing any calculations and work nothing out exactly. Okay, I'll see you in the next video.